Hi everyone, my name is Munib. I'm a PhD student at Oxford in engineering, and I'm going to talk to you about MM-GraphSurv. Building on some of what the previous speaker said, when we deal with clinical care when clinicians are making decisions, oftentimes they have to integrate information from multiple data sources, so multiple modalities. Some of the issues that some of the previous speakers mentioned is missing modality, what happens when some of that is missing. Some of it is also how do you correlate the modalities together, how do they relate to each other over time, and interpretability. How trustworthy are these models? Can we explain their predictions? So in MM-GraphSurv, our contribution is to build a novel multimodal graph neural network to model each of the modalities as a separate graph. And then on a higher hierarchical level, we can just fuse them. So when you have a missing modality, that graph just doesn't get generated, doesn't get added to the bigger graph. That's how we resolve that. The graphs we use to represent each modality are dynamic. So not just the time series, the vital signs, but also the radiography reports, the diagnostic codes, they're all temporal. So in that way, we can model the hidden correlations between the modalities over time. At the end, we're not just interested in predicting whether a patient will die or not. We're interested in predicting the risks of competing events. So oftentimes, for example, if you're in the ICU, the patient can die from multiple causes, and they're competing with one another to kill the patient. So we want to model that jointly, which is why we look at competing events. And here, we evaluated this on 5 data sets: ICU, emergency department, transplant data sets. And on the right, you can see a table. The bottom part is the emergency department. We can see how we can predict for ICU admission, hospital admission, and further observation in ED. Very, very well compared to like other baselines. And this is concordance, so kind of think of it as like accuracy or how well it's discriminating risk for these patients. When we look at interpretability, because we're working with graphs, we can just extract the graphs for each modality for each patient. So the size of the node tells you how important that feature is at that time point. The darkness of the edge tells you how important that relationship between those features is for that outcome. So over time, you can track these, right, over time steps. Dynamic evolving graphs across modalities, within modalities, patient, individualized, and specific. That's it. Thank you.